Sir, good evening, sir.
Good evening.
চিত্তবাবু এখনো ঢোকেননি মনে হয় স্যার।
তাই মনে হচ্ছে।
স্যার একবার কল করে নিন একবার চিত্তবাবু।
আচ্ছা ঠিক আছে, ঢুকবা। গৌরী, তাহলে প্রথমটা শুরুটা তোমাদের কলেজ থেকে কেউ করবেন তো নাকি? গৌরী, গৌরী।
হ্যাঁ স্যার, শুনতে পাচ্ছেন?
হ্যাঁ শুনতে পাচ্ছি। বলছি তোমাদের কলেজের কেউ এটা ইন্ট্রোডিউস করবেন তো?
হ্যাঁ স্যার, আমাদের এইচওডি ইনচার্জ আছেন, আমাদের এইচওডি একটু কোরিয়া গেছেন।
আচ্ছা,
তো
হ্যাঁ
ওনাকে
ইনচার্জ ঠিক আছে, যে কোনো একজন। হ্যাঁ, তিনি
ওনাকে আমরা
তাহলে
লিংক পাঠিয়েছি, উনিও যদি জয়েন করেন হয়তো 1-2 মিনিট বলবেন, তারপরে তারপরে আপনাকে চেয়ার সেশনটা করতে হবে।
ঠিক আছে। চিত্ত ঢুকবে বললো।
হ্যাঁ ঠিক আছে স্যার, আমি ওই আমাদের স্টুডেন্টদেরকে জয়েন করাই। স্যার অ্যাকচুয়ালি আমাদের এখানে ফুড টেকনোলজি আর এগ্রিকালচারের স্টুডেন্টরা গুগল মিটে জয়েন করেছে,
আচ্ছা
আর বাকি ইনস্টিটিউটের সমস্ত ছাত্ররা ইউটিউব স্ট্রিমিং এ জয়েন করছে। চিত্তও ঢুকে গেছেন।
হ্যাঁ এসে গেছি স্যার।
হ্যাঁ, গুড ইভিনিং স্যার।
গুড ইভিনিং স্যার, গুড ইভিনিং।
আপনি ছাড়া চলে?
এই তো প্রদীপ দা এসেছেন। নমস্কার
প্রদীপ দা, সব সময় ওবিডিয়েন্ট স্টুডেন্ট। প্রদীপ দা, গুড ইভিনিং। প্রদীপ দা
মিউট করা আছে।
প্রদীপ দা আনমিউট করুন। আচ্ছা, আমি আমার উইন্ডো গুলো অন্যরকম দেখাচ্ছে, কেন জানি না। শুধু আমার স্ক্রিনটা দেখতে পাচ্ছি আর ডিসপ্লেটা দেখতে পাচ্ছি, আর একটা জায়গায় 8 আদার্স বলে হয়েছে। প্রদীপ দা,
প্রদীপ দা শুনতে পাচ্ছেন না? Oh, I think all the people from age 80.
হ্যাঁ হ্যাঁ।
Yes, sir.
আচ্ছা, সায়ন্তনী কি এখন এইচআইটি তে আছে?
হ্যাঁ স্যার, সায়ন্তনী এখন এইচআইটি তে। ও
আচ্ছা
তো কৃষ্ণানন্দ যখন এসেছিলেন তখন থেকে আছে।
আচ্ছা আচ্ছা।
সায়ন্তনী একটা ভালো প্রজেক্ট এনেছে তো, আইআইসিবি থেকে আমাদের ইনস্টিটিউটে একটা ভালো প্রজেক্ট এনেছে। আইআইসিবি তে যে প্রজেক্টটা ছিল সেটাকে ট্রান্সফার করে এনেছে আমাদেরকে।
চিত্ত,
হ্যাঁ,
আইপিএস থেকে যাদেরকে রেকগনাইজ করা হচ্ছে তারাই পরে পরে হাইলি রেকগনাইজ হয়ে যাচ্ছে। আমরা আমরা আমাদের কি বলে আইআইসিবির কৃষ্ণানন্দকে রেকগনাইজ করলাম, তারপর সে এফএনএসসি, তারপরে হ্যাঁ, তারপরে ওই মিহিরবাবুর বৌমাকে কি জানা, রুচিরা না, হ্যাঁ, ওকে আমরা রেকগনাইজ করলাম, তারপর এবারে এফএনএ হয়ে গেছে। আরে আইআইটি বোম্বের
রুচি আনন্দ,
রুচি আনন্দ, হ্যাঁ রুচি আনন্দ, ও এবারে এফএনএ হয়ে গেছে। আচ্ছা, 6:20 বেজে গেছে।
তাহলে আমরা শুরু করে দিই।
হ্যাঁ শুরু করে দাও। 44 এখন অ্যাটেন্ড এখানেই 44।
হ্যাঁ স্যার, এটা বেড়ে যাবে। So, good evening, everyone. Nice to meet you all again. It is a very memorable day to all of us. As you know, the Padma Vibhushan Professor
Hello.
M.S. Swaminathan has died a few days before,
হ্যাঁ
and we have organized a conference in his memory.
ওটার
He
মধ্যে
is
নেই
known to be the
না ক্লিক করলে হবে না ওটা হ্যাঁ আসলে এখন তো আমি এতে ঢুকে গেছি গো হ্যাঁ হ্যাঁ তোমাকে হোয়াটসঅ্যাপে করেছি তো
স্যার আপনি একটু মিউট করে দিন
হ্যাঁ ওই ফ্ল্যাশ থেকে লিখে নাও না একটু হুম,
স্যার স্টার্ট করবো
চিত্ত,
হ্যাঁ হ্যাঁ হ্যালো
হ্যাঁ
হ্যাঁ ইয়েস স্যার ইয়েস স্যার ইয়েস
তুই
স্যার
তুই কথা বললে মিউট করে দিবি, হ্যাঁ নিজেকে। ঠিক আছে, গৌরী স্টার্ট কর।
So, yes, so it is a very memorable day to all of us. As you know that Professor Swaminathan has died just few days before, and we have
এখনো
arranged
জানি
a
কথা হচ্ছে।
memorial program for his memory. And he is known to be the father of green evolution in India. And today, what we are enjoying that in India we are very that is independent in our food capacity. And today our Prime Minister has already inaugurated the Millet Day in New Delhi. So I think it is also a pride day to all of us. That is today we are celebrating a seminar on the memory of Padma Vibhushan M.S. Swaminathan, and the same day our government is celebrating a day in the millet in our national capital. So without much delay, I will just give a brief introduction of the program. It is a one-day seminar in collaboration with the Indian Photobiology Society and School of Applied Science, Haldia Institute of Technology. And myself, Dr. Gauri Shankar Aimotra, is the convener of the program. Today there will be three speakers. The first speaker is Professor Chittaranjan Sinha. It is the first session which will be that is chaired by our president, Indian Photobiology Society. And before we start the program, today our HOD is in Korea. He is in a trip. So our HOD in charge, Professor Anupam De, Associate Professor of Mathematics, he will just say a few words about our department and about the program. And we got a much help for the last 2 days to organize this program within a very short period. That is so a big thanks to him. And in this connection, I will invite Professor De to say a few words about our department. And today in this seminar, our students of agriculture and food technology, they have joined in the Google Meet, and other students have already joined in the YouTube streaming. So all the students from our institute are joined in YouTube streaming. So for the actual audience you are seeing here, the actual audience is much more of that. So we hope that the seminar will be successful. With this hope, I just invite Professor Anupam De to say a few words. So now I will ask Professor Pradeep sir to, if your microphone is available, if you say 2-3 minutes to our students, because you are the senior most participant today. So your blessings is always helpful to our students. We generally do not get chance to interact with you. If you just say a few words to our students, then we will start the program. Pradipta sir.
Pradipta, please unmute yourself. Fine, fantastic.
Well, these IPS seminar series
I think there is some internet problem.
I think there is some internet problem. So I think we can interact with him in later on. So Nitin sir, if you just proceed the session. So I will now invite Professor Nitin Chattopadhyay to preside over this program. Nitin Chattopadhyay is the president of Indian Photobiology Society, and he is a senior professor of Jadavpur University, Department of Chemistry. And
ম্যাডাম স্যারকে বলুন আজকের প্রোগ্রামে জয়েন করতে, এই তো আরম্ভ হচ্ছে।
So I will request Professor Chattopadhyay
হ্যাঁ
to start
হ্যাঁ
the session.
লিংক দেওয়া আছে তার মেলে, হ্যাঁ ইমেলে দেওয়া আছে।
Good evening, everybody. Let me first invite everybody, faculty members, scholars, and all the students to this one day and evening conference, which will be constituted of three talks by three eminent speakers. The first, the occasion is, we all know that just about a month ago, Professor M.S. Swaminathan, who is called the father of Green Revolution, he passed away. And so in his memory, to pay homage and respect to him, we from the Indian Photobiology Society, together with the Haldia Institute of Technology, we are organizing this thing, today's event. The scarcity of food in India. The present generation, young generation, they cannot feel that position. But in fact, he first introduced these chemical fertilizers to make or to produce more and more food crops and many other things. Of course, it has positive and negative both the ways, because now, yes, we are self-sustained in food grains and in all foodstuffs, particularly green ones. But it has its negative impact also. And many of you must be knowing that Punjab is the capital city of cancer in India. And if you just try to correlate, this green revolution started from Punjab itself. So there is a direct one-to-one correlation. Like anything, any event has some positive thing and some negative thing. If you argue that in that case he could not do this thing, that is also not acceptable, because in that case we had to suffer because of the scarcity of food. Anyway, he contributed immensely in our food production. So to pay homage to him, to his departed soul, let us listen to these three speakers. The first speaker is, he is well known to all the participants here, because every now and then you get communication from him regarding the activities of Indian Photobiology Society and in many respects. The first speaker is Professor Chittaranjan, Sinha, my colleague, my brother. So he will be talking
Good evening, everybody.
Okay,
Audible? May I audible?
you are audible. So
Okay.
let us invite Chitto, and he will tell the
Uh,
title and everything. There is hardly anything new to this audience, so I am just skipping because of the shortage of time. He is in chemistry department of Jadavpur University. He is an excellent researcher, excellent teacher, and a person of different level. He is extremely busy all the time with his very thin figure, and he gets involved into all academic as well as social activities. So he has already published nearly 500 publications in peer-reviewed and well-established journals. Okay, Chitlu, you please start.
okay.
Chitlu, please.
Is it visible to you all, this my slide?
Yes, slide
Yes,
is.
sir. Yes, sir.
Okay. So, thank you, sir, for giving me this chance to introduce myself in this auditorium, in this audience, gathering from particularly the participants from Haldia Institute of Technology, thanks to the persons from Haldia Institute of Technology, particularly Professor Raima Patro and other members of the Haldia Institute of Technology, those who are tirelessly working and supporting Indian Photobiology Society. And already the students, those who have joined here, they know the MS Swaminathan, who has the contribution to the self-sufficiency of Indian food crisis, particularly just before the independence. Even after independence, there were also problems. And let us pay our respect to our MS Swaminathan, visionary father of Indian Green Revolution. And, and there are three speakers already informed, and out of them, two speakers will talk about the self-sufficiency of Indian food production in independent India and also in the future India. Since you know the India is the most populous country in the world, and it is running 144 crores of the people, and the government has feed all these people along with all other needs. That's why the use of this agriculture technology, and today for the sustainable development purpose, certainly some things we have to compromise: production, quality, sustainability, etc. That will come forward. Gauri, it is difficult to continue the admission of the people who are going to join with the program.
No, no,
And
sir. That I am taking part.
please, you take care of it.
That I am taking part.
Okay. Today my topic is, since the food security or food safety part will be taken in the next two lectures by the experts. I don't have any expertise in this field, rather the food adulteration and detection, since although we are taking food, but the food in fact controls our health, not only the personal health, family health, social health, and everything, and the whole life processes. So I will talk about this food adulteration and detection. You see, what is food? Food is the substance that is consumed by the living organism for nutritional support, and it helps for the normal functioning of the biology. Food is usually of plant, animal, or fungal origin and contains essential nutrients. Those are necessary for our survivability. And in terms of the chemistry, the food contains carbohydrates, fats, proteins, vitamins, or minerals, and they have the different value. Value means the energy value. In terms of the energy value, you see in the food pyramid, the consume adequately this part, that means the cereals, bread, rice, pasta, etc. This group of the foods what we can consume in large amount, in a sufficient amount,
Sir, your slides is not moving.
Huh?
Your slides are not moving. You have to click on the left hand side slide.
Oh. Then I have to leave the. Is it
You
okay?
can,
Yes,
yes,
yes, yes,
yes.
yes.
Then I have to maintain this planning of the presentation, not to the full panel. Is it visible?
Yeah. No,
Yes, sir, yes, sir.
Okay, okay,
Chitto,
okay.
you can also make the full slide visible, and in that case, you can just move it one by one.
Is it visible to all?
Yes, it's visible.
Okay. In that case, you see the eat sufficiently, that is consume adequately. This part is the carbohydrate part mainly, and but the eat liberally. That is, you see the vegetables, fruits, this part, while the eat moderately, that is the meat, fish, dry beans, eggs, etc. That is protein parts commonly, while the eat sparingly. This is the processed food. So processed food and other foods in the food pyramid, you can recognize what the amount of food you can consume for the sustenance of a life, and the amount of energy necessary for a common man, ordinary man, that depends on the work what that person is doing. That human body commonly needs 1800 to 2600 kilocalorie per day. That depends on the age, health, and activity, as well as any sorts of the problems he carried. And those are suffering from diabetes, certainly they will consume the left side amount, that is in the less than 1800, it is around 1600 or less, that depending on the person concerned. So this is the food what we can consume, the different types of foods. And for the preservance of food, since we have to in the crop production once in a year or twice in a year is performed. So you have to preserve that food for the whole year. So retentioning the quality of food, we have to preserve it for longer period, so that the nutritional value of the food remains fixed. There will be no compromise with the nutritional value, but the food preservants that sustain the food quality and food life. Food life, that means the food you can preserve for a period, that is food life. So the preservant, there are different classes of preservant, natural preservant and synthetic preservants. Natural preservant, they are antimicrobial agents coming from the nature, antioxidation agent from the nature. While the synthetic preservant, they are also antimicrobial, antioxidant, but they are the chemical preservants. So edible substances which we generally we mixed or the coated with our common food, there are different types and polysaccharides, chitosan, or the starch, or the soya protein. These are the different types of food materials or the food additives, food preservants are added to improve the food quality as well as to improve the sustenance of food. Sometimes, garlic, garlic drops, garlic drops or cinnamon drops, they are the antimicrobial. They improve the food life. That's why the sometimes cooked food with some masala, that cooked food has the longer sustenance. Even the food pH, that after cooking, cooked food of low pH, the acidic, that cooked food can preserve for longer period. At home, or if you go to restaurant, you can have the cooked food with some the tasty of sour tasty by using the vinegar or some other. At home, we are using the turmeric or some orange juice for the preparation of this cooked food to increase their lifetime. So these are the preservants. and food additives. So food additives and food preservatives are necessary to improve the sustenance of food and to preserve the nutritional value of food. And you see, then the food preservation method, the common process is the drying. It is commonly well known to us. Drying, chilling, freezing, canning, smoking, and pasteurization. These are the physical methods of preservation, while the chemical methods, salting, pickling, sugaring, all these are the sugaring, these are the chemical methods and physical methods for the food preserving processes. You see the different types of fruits, they are being dried, the dry fruit. Dry fruit we usually consume, see, the nuts or the betel nuts or all these are the dried and we consume it. And while the chemical preservatives, you see, there are a lot of examples of the chemical preservatives. Common is the acetic acid, vinegar, which is used. Vinegar, benzoic acid, the sorbic acid. Sulfur dioxide is also used. Sulfur dioxide gas is passed to maintain the microbial status of the food materials. Even the sodium and potassium nitrates, these nitrates are also used as the food preservatives, but be cautious since nitrates are releasing the nitric oxide. So this nitric oxide is detrimental to human health at higher concentration. Although the nitric oxide is cardiovascular signaling molecule, but at higher concentration it is very dangerous. And for the meat preservant, commonly sodium nitrate or potassium nitrate is used for meat preservant. So in that case, the meat looks very bright red, and you can see that as if it is a fresh one. Or you see the artificial sugar like saccharin or the aspartate, all these are the artificial sugars or different types of masala. These different types of smelling agents. Smelling agents are being added to your food to attract the customers. So that is the food preservatives, food additives are added along with the adulteration. Adulteration, see, many of us, particularly our student, this present generation is very much habituated to consume the the processed food and soft drinks of the different colors, and we are purchasing fish from the market, and these fish, you see, commonly the fish what we are purchasing from our local market, they are coming from Bilaspur, and many of us well known that Bilaspur fish, that is, they are coming from Andhra. To bring that fish into our market in Kolkata or West Bengal, the Andhra fish, it needs at least 2 weeks to reach. So certainly that fish cannot be in good condition or the fresh condition when it will come to your market, or if you purchase it from the market at kitchen. So it is a rotten fish. But the preservant what they use, in many cases they use the pesticide. And these pesticides, fish, they are sprayed with the pesticides. If you go to Digha, Shankarpur, where the dry fishes are being produced, the Balighai is one of the well-known place in East Midnapur, nearby our house. There is one market. It is the largest dry fish market in the country. And these dry fishes are being produced in that area, particularly Digha, Shankarpur, and this area. They are using different types of pesticides to avoid any types of corruption on the fish body. So these pesticides are commonly very dangerous, organochlorocompounds or organosulfur compounds. I will tell you about these. So these are the adulterated system. Besides many other, you know the fresh fruits, what you are getting from the market is in the apple. You can have the apple; those are very bright, and this bright apple they are coated with some materials or some other polymers, and we are consuming all these things. Even the tomato, the all other vegetables, they are being also colored, and the spinach what you can purchase from the market or looking fresh, but they are not at all fresh. They are being dipped into copper sulfate solution or some blue solutions, ultramarine blue. In that blue solution, they dipped it and then collected from it, and it looks like fresh. So all these are the adulterated system to attract the people. Although we have the food quality control department in every state, in Kolkata particularly, there the CIT market, that is regulated market. In that regulated market, the food quality control department of the municipality or corporation, whatever may be, and they have the right to check the food quality. And I'm sure that they are not checking it, since I have that experience on purchasing fishes from Jadavpur market. Okay, that is another story. But this food adulteration, what if we consume this type of food, what happens? The nervous damage, vomiting, fever, paralysis, cough, etc. In 1988 in Behala, that thing happens. Just let me to show you this picture, then you will recognize it. In 1988 in Behala, by consuming mustard oil episode, this notorious mustard oil episode in Behala in 1988, July 17, 30 paralyzed and 2,500 people hospitalized because of the addition of this tricresyl phosphate in mustard oil. This tricresyl phosphate is coming from the rapeseed oil. Rapeseed oil that time price was 14.40 per gram per kilogram, while the mustard oil price was 26 per kilogram. So certainly that adulteration of the mustard oil by rapeseed oil as well as tricresyl phosphate causes this adulteration, and that leads to the effect is the weakness and paralysis of the hands and feet on both sides of the body due to damage of the peripheral nervous system, which is known as the polyneuropathy. It is not only the phenomena, this is, this picture you see, that happened in Bihar. This is the same reason that boy died later on because of this mustard oil adulteration. And this adulteration can be easily tested at home by adding the nitric acid. This is the unadulterated mustard oil. This is adulterated mustard oil. You take this mustard oil, add few drops of water, and then add concentrated nitric acid and shake well. If it is turned to red, then you can convince that mustard oil contains this triorthocresyl phosphate or the rapeseed oil. And in that way, you have to recognize or detect this adulterated food. This adulteration can be done by natural way or some intentional or unintentional, and many ways it can be done. Commonly, the business persons, they are they are doing it both. I think for the last few days you heard of it, the ration corruption, what is going on in our state, and that time minister is now in jail, and that ration corruption also one type of food adulteration. That is an organized food adulteration. In an organized way, they are doing it. So that happened in our whole country, not only in the part of the country. This is the whole country. Business persons are doing it for the larger amount of profit. And types of adulteration: intentional adulteration, what is happening, metallic contamination, incidental adulteration, packaging adulteration. Commonly, we carry the food on the aluminium foil. Through this aluminium foil on packing, the hot or cooked food quickly on the aluminium foil will bring aluminium in your food. That will also causes different types of problems in biology. And types of food adulteration: on cooked food, on fish, on fruits, vegetables, on any kind of fruit or the food products what we are consuming. What types of adulterant added? You see, on bread, substandard yeast is used so that the yeast fermentation is incomplete. So that created a digestion problem, and as well as diarrhea, vomiting, allergy, etc. In banana, aldrin is one organochloropesticide that causes convulsion, loss of consciousness. In beans, you see in beans that the beta BAC, this is also hexachlorobenzene, and also respiratory damage system organochloropesticide, and lead contaminate in your curcumin powder or turmeric powder, lead lead chromate is added. Lead chromate, yellow in color. And some arsenic, chromium, they are also added in the rice, the solid, some stone chips are added into the rice to increase its weight so that the profit may increase. And DDT in the fish, you see, already I told you some different types of organochlorocompound. Thymate is one pesticide used by the farmers. That thymate or DDT was sprayed over the fishes, so also on the dry fish, that created cancer. On the apple, alpha chlorodone, this is also an organochlorocompound. They are adding in the apple. In milk, there I will tell you later on about milk, and the huge amount of contaminants and pesticides and adulterants are added into this. So there are varieties of, in the fish, in Diga, where the fish is catching by the fishermen, they used to collect fish when they go to sea. After 2 weeks or 3 weeks, they will come back to the shore and transfer the fish. But it is 3 weeks, fish cannot survive. What they do now, they collected the fish and put into the formalin solution. In biology laboratory, all the species are being preserved in formalin solution. That formaldehyde solution causes the species very hard. What you are collecting, the fresh fish from the market, those are not at all fresh. They are all added with the formalin. The formalin causes the bronchial problem and also cancer. So all these are the different types of pesticides added into our foods. And food adulteration in India, there are some rules. Government has enacted rules in 1955, and we have the Food Safety and Standard Authority of India. A Food Safety Standard Authority of India, they commonly provide the certificate to consume. So FSSAI, that stamped food packet, there will be nutritional value, etc. on the food. And you see that 26,000 food samples were found adulterated or misbranded in 1819 year in
root, Indian shoot, granola, purple yam, air potato, elephant food, and these are all highly nutritious if I compared with the other tubers. Wing bean, lima bean, cowpea, horse gram, rice bean, velvet bean, and ajushi bean. So these are all underutilized, highly nutritious legumes. And if I talk about millets, that particularly the small or minor millets, they are basically cultivated as a traditional crop in red-fed areas of semi-arid region where rainfall is very restricted, soil is not fertile for any other crops. And they are finger millet, foxtail millet, proso millet, Latin millet, barnyard millet, teff, kodo millet, fonio millet, job steer, guinea millet, and brown stalk millet. But the introduction of this cash crop, rice, wheat, has restricted their cultivation in the particular marginal areas. So if I talk about the history of origin of this millet, aquatics has been already exist more than 8,000 BC, when rice has come much later, 4,000 years ago. So you can see that our ancestor, all of them are using these millets as a staple crop. If I talk about the statewide production of millet, so if you talk about area, then Rajasthan and Maharashtra. If I talk about the yield, then I talk about this state Tamil Nadu and Uttarakhand. So these are the two states who produce more millet in terms of kg per hectare. So what is the difference before Green Revolution and after Green Revolution? If you see the different color code, then blue color code is the area, and green one is the production, and this brown color is the yield per kilogram per hectare. So this 1965 to 70 is considered to be the Green Revolution, when this dwarf gene of wheat, RST gene, has been brought by Norman Borlaug through the CIMIT Mexico to Professor Swaminathan, and Professor Swaminathan used this dwarfing gene to cross it to the Indian cultivars, and that's why the Indian hybrid, those who have been dwarf in size and high yielding, has been developed during 1965 to 70. So if I see before 19th Green Revolution, this era, before Green Revolution, the area of cultivation of millets is more, but the production is less. And over the time, the introduction of cash crop, this production has basically gone down, area gone down actually. So, but the production has been increased, but due to intervention of these good varieties. But this is the main reason why this millet has been dropped because after Green Revolution, due to the introduction of the cash crop like rice and wheat. So if I talk about the importance of the small and minor millets, we have recently published it in the Trends in Plant Science. What are the importance of this millet? If I talk about this finger millet, this ragi, so it is very rich in calcium and polyphenols. So good for the osteoporosis, those who have bone-related issue. You don't need to intake any supplementary pills. If you take at least once in your food diet, 3 times food, the finger millet or ragi, then I think your calcium deficiency will definitely will increase, actually decrease actually. So what are the important of these minor millets? They are agroecological nutrition quality and potential to ensure the immediate demand of food security. So they are much superior in terms of agroecological, nutritional and potential to ensure immediate demand for food security. And they, top of this, they have better water and nitrogen use efficiency, so they can withstand in a very water limited condition. So if I talk about the comparison of this minor millet in terms of 100 gram of grain, in the protein, fat, as crude fiber, carbohydrate, energy, and vitamin, thiamine, and riboflavin for all the minor millets with rice, wheat, and sorghum, you can see here, if you any data you take, all the minor millets are 3 to 5 times much superior as compared to rice and wheat and sorghum. If I talk about the micronutrient, calcium, potassium, magnesium, sulfur, zinc, again, all the minor millets are 3 to 5 times more superior than wheat and rice. Now, the question is, this traditional cultivar aspect of millet in the context in Yajurveda, it is already reported in the text that that Priyangava, this is known as foxtail millet, and Anava, the Barnier millet, and Samaka, this is black finger millet, they have been already utilized by the our ancestors. And this millet consumption was very common, predating the Indian Bronze Age of 4500 BC. And this is the great historian, this Meganthes. So he also has said that this millet has been widely cultivated during the era of Chandragupta Maurya, 302 to 293 BC. That cultivation and consumption of millet in India. So in the history also it was reported that millets has been widely used by our ancestors. Even if we talk about the Chanakya Kautilya's Asasastra, he wrote that Kodrava, this is Kodo millet, and Prahangu, this is foxtail millet, will increase 3 times the original quantity when it cooked. Grains will increase twice the original quantity when it moistened, and 2.5 times when the soaked with sprouting condition. So these are all culinary properties of Kodo and foxtail millet, which is already described by the Kautilya's Arthashastra, and it was already identified that they have been traditional and cultural aspect of millets in the context of Indian point of view. So if I compare with this, the health benefit of millets, so they are, firstly, they are gluten-free. So many people we have in the world that do have allergy with this gluten, but all the millets are gluten-free. They are good diabetic food because you know that due to presence of good resistant starch and the low glycemic index, all the millets are very safe for as a diabetic diabetic food, because due to presence of good high resistance starch, the conversion of carbohydrate to glucose is very slow, and that's why the body can adjust that sugar level. Mineral rich food and antioxidant, and then multi-beneficial food, and then food for lifestyle diseases. So these are the comparison of millet bread and the maida bread actually. So millet bread is that gluten free, where the maida is lower fiber, high in nature, less in nutrient, high energy, digestive issue, and rich in nutrient and weight gain. So maida bread is not good, and the millet bread is much better for its consumption. So if I talk about the socio-economic aspect of millet in the context of India, you can see that it was already reported that the millet cultivation can ensure livelihood security and economic empowerment of resource poor farmers. Millet, as I said, the millet can grow on poor soils with little or very less external input. It requires very less water, half the water required to grow rice. Survive in high temperature, it can grow up to 40 and beyond 40-degree temperature. And moreover, it is a C4 photosynthetically efficient crop, where which produce more economic returns or with lesser inputs. So if I talk about the popularity of millets, nowadays the millets has been gaining high popularity. And if I want to buy any millet in the supermarket, it costs more than 100 rupees. You can get rice in 40-50 rupees, but not millet actually. One time Professor Swaminathan said that in 1980s that millets are poor man's diet. Yes, at that time millets was poor man's diet. But at the present context, it's not a poor man's diet, it's a rich man's people diet. If you say here, I went to several part of a country, and when I went to southern part, like in Coimbatore, in one Arya Bhavan at Nagarkovil region, I found that there are 6 different kind of dosas as available, like ragi dosa. Then you can find is this the foxtail dosa, and then the banded millet dosa, and these 6 different types of dosa cost more than 100 rupees per dosa. But for normal dosa, you will get 50, 60 or maybe 80, but not the millet dosas. If you see the super Bollywood movies in the 60s and 70s, here you can see here all the pictures has been taken behind this pearl millet field. Actually, you can see here the millet, the background millet, but now it has replaced by brassica, the sarso ka khet. So keeping in view this importance of these millets, minor millets, the government of India has recognized its potential, and through a gazette notification on 10th April 2018, and they have termed all these minor millets as the nutri-cereals for production, consumption, and trade point of view. And the Food and Agriculture Organization has designated the year 2023 as International Year of Millet. So I will show you some video, a 2-minute video. I hope that you will enjoy.
I may be small, but I am strong. I grow where others cannot. I thrive in harsh and dry conditions, providing food when other harvests fail. I nurture soils and ecosystems and boost biodiversity. I am nutritious and innovation. I want to share my benefits widely with all people and the planet. But I cannot do it alone. So bring me back to your table. I am millets.
So you see, I have that FAO has developed this, produced this to aware the people that you bring this millet at least once in 3 meals, actually, either in breakfast and you will get it like soulful, Tata Soulful. They have ragi, cornflakes and others, ragi biscuit also. So you will get, there are several millet-based products now available in the supermarket, and it's very highly priced because the production is very less but demand is more. So most of the thing has gone abroad. So what I have done that we have asked a question: can millet address the hunger issue? The answer we have write in a opinion article in Trends in Plant Science. And as I said that based on this color code, this South Asian region, including that some part of India, this 52 countries now become 55 countries now become after COVID-19 82, that really there have been really hunger region, and here also immediate intervention of millet is required. And for that, we have proposed a roadmap. We have to identify the millet species which is suitable for cultivation of the hunger hotspot. Because as I know, that this barnyard millet is very good as far as the soil of Madurai district of Tamil Nadu and the other climatic condition is concerned. So farmer has to identify the right millet species to cultivate based on the soil and the agroclimatic region. And then we have to optimize a cultivation practice and training of farmers for millet cultivation, because you know that farmers are trained with rice and wheat, but they are not well equipped with how to do millet cultivation. And then we have to implement the large scale production of millet species. Optimizing the downstream processing is very important. And here, intervention of the genetic, like people like us, is important for the development of this genetic improvement of the millet variety using modern biotechnical approaches. And then the third one is the last one is a very important for any of these food crops, appropriate strategy for post-harvest processing, storage, and supply chain. So if the farmer produce anything, it should go to the market without any hassle. And if you want to know more about this, then you can read this our opinion article on small millet enduring food and security amidst pandemics. So now I will show you some one of the important story of was how this we decipher the function of the abiotic stress related genes for answering the question. So this is she is my Charulata is the second PhD student, and she has characterized these dehydration responsive element binding transcription factor gene in foxtail millet, and she has got all the awards and rewards which is available in the government of India. And she has been posted in CSR NBRI Lucknow as one of the senior scientists. Now she's transferred due to family reason to the NISP in New Delhi. So she has identified one SNP in the DRAPE gene. This is the gene, DRAPE gene, and identified a SNP, single nucleotide polymorphism at 558 base pair. These four lines are basically a susceptible genotype, and these four lines is H genotype. SNP is this tolerant genotype, and she has developed one allele specific marker which can act as a diagnostic marker to distinguish the tolerant variety with the sensitive variety. So you see that if you identified a diagnostic marker from a gene itself, that is very important for initial screening of the which variety will be tolerant, which variety will be sensitive against this drought tolerance. So for any gene family, there are more than 100 genes. So it's very difficult to characterize 100 genes. So we have to devise and practice how to do this. And for this, we are very fortunate that in the year 2012, two groups, one from American group, Benedict group, and from Chinese group, they sequenced the foxtail millet genotype. Among the 10 minor millets, foxtail millet is the only millet which is diploid. Other millets are polyploid. So working in polyploid species is very difficult, but diploid is much easier. Rice is also diploid. So by the help of this sequencing information, we have developed several open access databases like foxtail millet marker databases, transcription factor databases, microRNA databases, and transposable allele-based marker databases. So these open access databases has been integrated with the comparative mapping tool, so that researcher can do comparative mapping, and we can find the ortholog or homolog with rice, maize, sorghum, and brachybodium with foxtail millet. So coming to this another gene characterization, I have talked about that Charu's DRAPE genes, which she has developed the SNP marker, diagnostic marker, which can distinguish the drought tolerant and sensitive variety. Similarly, Roshan has characterized the heat shock protein. You know that heat shock protein was also present in human. And like Charu, he also got the ICR Jawaharlal Nehru Award for outstanding doctoral thesis research for this characterization of the heat shock protein gene. And I will show you some work. So heat shock protein are what basically they regulate different aspects of stress defense through protein-protein interaction of the target protein. So there are different kinds of heat shock protein, the HSP 70, 90, 100, HSP60 and small hits of protein. So when Rawson tried to find out how many HSP genes are present in foxtail millet through HMM profiling, he identified there are 113 HSP genes are there. And you can see here these 5 different categories of HSP gene has different numbers. And to quickly check the expression profiling, he did some this RNA sequencing thing. Before going to this, as I said, that we have done have a very good collection of foxtail millet accession, and then we try to understand that which are the highly tolerant variety and highly susceptible variety in terms of drought and heat tolerance and salinity tolerance. And through biochemical and physiological parameter, we identified that IC4 is a highly tolerant and IC41 is highly sensitive. So these two contrasting genotype of foxtail millet has been used for doing all these expression study. Like in Charu also used these two contrasting genotype. So Rawson did 113 HSP genes, the RNA-seq to find out this. You can see here with this IC4 and IC41, these are the two contrasting genotype over different time interval. 0 hours is control, 6 hours, 12 hours, and the red color shows the highly expressed gene, and the green color shows the down-regulated gene. And this is basically I show the traffic light to check which gene is highly expressed and which one is down-regulated. And based on that, he identified one small heat shock protein, that is HSP27, which is differentially expressed in dehydration, heat, salinity, and cold. So you can see that out of 113 heat shock protein, how he pinpoint a single HSP gene which was differently expressed in all the 4 abiotic stress conditions. And when we check the individual stress with this expression value, we found that this HSP27 gene was highly expressed, 35-fold in tolerant cultivar during heat stress, 21-fold in cold stress, 47-fold in salinity, and 7-fold in dehydration stress. So what is the reason for this high expression? So when he checked the promoter of this HSP27 gene, he identified that there is a signature element, heat shock element, with this signature is present. This heat shock element are the binding site for transcription factor, that is heat shock factor, transcription factor, which regulate after binding on heat shock element the expression of HSP27. And through expression and co-expression study, he identified the heat shock factor binding factor here in heat shock element of the HSP27 gene and regulate the expression. And then he silenced this HSF2AE transcription factor to know whether this silencing means down regulation of this gene will affect the expression or not. And he found that through virus-induced gene silencing, that if we silence this HSF2AE transcription factor, HSP27 gene also goes down the expression. So indirectly, it shows that yes, this HSP27 is the main transcription, this HSP gene, which was controlled by the transcription factor, H factor A2E. Now the question is, this HSF2AE transcription factor is relevant in the expression of this HSP27 gene or not? For that, he used in vivo and in vitro. So in vitro, he used yeast 1 hybrid assay, and in vivo in planta, he used this luciferase assay. So when this transcription factor HSF2AE and HSP27 is there, you can see a signal is there. When he mutated this HSP27, there is the signal goes down. So it shows that indirectly that heat shock factor A2E, the transcription factor, directly regulate the expression of this HSP27 in response to high temperature stress. Then he checked that whether this HSP27 has the thermal aggregation or not, and for that he used 2 substrate proteins, cited synthase and alcohol dehydrogenase, and he heated it at 45-degree temperature and over the time. And then he measured the relative scattering, and he found that when HSP27 is there, the scattering is less. Without HSP27, the substrate protein scattering is more. So it shows that HSP27 prevent thermal aggregation of the substrate protein cited synthase and alcohol dehydrogenase. So the basic take-home message is this: HSP27 is there, scattering is less. If it's no HSP27, scattering is more. So HSP27 prevent thermal aggregation. Then he checked, because this is a molecular chaperone, so it should have the protect the enzymatic activity of heat inactivated protein. So what he has done, Rosen, then again he heated this cited synthase, that the substrate protein, at 45-degree temperature over the 40 minutes, and then it cool down to the room temperature 25 degree. So you can see that HSP27 150 millimolar, it can regain 40% of its enzymatic activity when it comes to the room temperature. But without HSP27, it can go, the activity goes down. So HSP27 prevent irreversible thermal inactivation. And then when he increased the millimolar concentration, 50 millimolar to 600 millimolar of HSP27, this 40 percent now becomes 60% enzymatic. So if you increase the HSP27 concentration, the enzymatic activity also increased from 40 to 60%. So when we check the localization of this molecular chaperone HSP27, we identify that it is a chloroplast localized, not in the cytoplasm or mitochondria. It is only localized in the chloroplast of the plant cell. Then when we try to find out the target peptides which is interacting with the HSP27 of FOXT10 millet, he identified that there are almost 70 to 80 peptides which is interacting with HSP27 of FOXT10 millet. They have been characterized in photosystem 2, 1, molecular chaperones, and proteins associated with photosystem 1 to light harvesting complex, and then also the chloroplast localized protease photosynthesis related enzymes and proteins through proteomics approach. When Rosen checked the phylogeneity of this HSP27 of FOXT10 millet, he found that this HSP27 of FOXT10 millet only sequence is present in C4 panicoid grasses, not a single one in C3 or any dicot species. And this is a small hits of protein, it has 642 base pair base, and the HSP27 is 213 amino acid. So when to check this stress tolerance, he overexpressed this FOXT10 millet HSP27 in the rice cultivar IR64, and he has developed a good amount of transgenic rice line. And when he evaluated the transgenic rice lines over these different agronomic traits and overall yield, the transgenic rice lines, they perform better as compared to the wild type in terms of plant height, number of tiller per plant, number of grain per panicle, panicle length, panicle per plant, number of panicle grain yield per plant. There is no change in length per 10 seed gram and 100 grams of seed. So transgenic rice line equals L1, L4, and 10. They all showed improved agronomic traits as compared to the wild type, where this HSP27 gene has not been transferred. When then Rosen has evaluated this transgenic rice line in the current scenario. So you can see here rice grow on 24 to 28 degree, but the current temperature when the rice grown season is more than 40, according to the last 10 years data. And IPCC also said that 4 to 5 degree rise in temperature by 2050. So if a rice grow on 24 to 28, how you will get yield in 40 degree temperature? So Rosen mimicking the natural heat stress condition starting from 32 to 45 degree temperature in the phytotron of our facility, and evaluated this in continuous stress condition. And then when we check the morphophysiological response of the 3 weeks old rice seedling during high temperature stress for 8 days, followed by recovery of 7 days, he found that only 22% of the wild type plants without HSP27 is surviving, when 80% plant transgenic rice line they are surviving. When we check the ROS activity, he found that in the control plant, ROS activity is more high as compared to the pre-transgenic rice line. You can see also here that the lipid peroxidation electrolyte leakage is also more in the control wild type as compared to the rice transgenic line. So in nutshell, I can say that HSP27 improved high temperature stress tolerance in transgenic rice line. So when he checked the photosynthetic parameters by using the infrared gas analyzer IRGA, commonly known, he found that the total chlorophyll, chlorophyll A, chlorophyll B, they are all performing much better in the rice transgenic line as compared to the wild type. When we check the protein of this rice transgenic plant and over the wild type, he found that yes, that all there is no much change in the transcript level, but when we talk about the protein level, that there is a huge change. The rice transgenic plant protein was not degraded as compared to the wild type plant. Wild type plant protein has been degraded since there is no presence of HSP27. But in the rice transgenic line harboring this HSP27 of foxtail millet, the protein is not degraded. So that is the reason why they are surviving in the high temperature stress. So when he checked the yield, over yield, so he found that this wild type, there is 35 to 45% of yield penalty, where wild type has 70% of yield penalty. So HSP27 of foxtail millet minimize yield penalty under continuous high temperature stress transgenic rice. So if I conclude my talk, I can say that what I have showed today, that foxtail millet HSP27 is a unique panicoid group of cereal. HSP27 is a chloroplast localized molecular chaperone. HSP27 protects several chloroplast protein during high temperature stress. HSP27, when we overexpress this in the rice transgenic line IS64, and it improve high temperature of 45 degree, it can maintain the higher photosynthetic efficiency. And if we talk about the yield, rice transgenic showed reduced yield penalty 30 to 40% as compared to the wild type of 70%. So HSP27 maintains chloroplast protein and improves thermotolerance. So that is the story what Rawson has showed about the HSP27. We have published it in a high impact journal, more than 9 impact in the cellular molecular life sciences, and we have also filed a patent for that development of this. So what I have said today, that millet are the wonder crop in terms of abiotic stress condition. I have showed today that how integrated multiomics approach can help us to identify the candidate gene, and by using either genome editing or by overexpression, we can develop a climate smart cereal crop which can cutter the high temperature drought or soil salinity. So the long-term goal, designing cereal crops which are more durable in adverse climate condition amid threat of global climate change to ensure the food security in 10 billion. So that's all from my side, and these are the students' achievement. I have talked about Roshan. He has recently got the assistant professor position in the Mahishadal Raj College, Vidyasagar University from West Bengal. So he is a junior from the Botany Department of Calcutta University. And Muthu is assistant professor in Hyderabad. He has developed all the databases of foxtail millet. Charu I have talked about, that he has characterized the drape transcription factor. Swati characterized the neck transcription factor, and these three fellows they work on my other project, that virus interaction. So that's all from my side. Thank you very much.
Thank you, Dr. Manoj Prasad. Fantastic talk it was. Very explicit scientific observation. So this sort of research is really needed in our country. But unfortunately, as we all feel that there is a huge gap between the lab. You are muted. Okay. Until he responds, I have a small query, of course, very important query, Dr. Prasad.
Yeah.
What about the physical, or what is the effect on physical side or physical aspect for these transgenic crops?
Look, in Bengal, I know that all the brinjal you were eating, it is all transgenic, BT brinjal. Okay.
Mhm.
But it was not released by the government of India, but it was released by the Bangladesh government, and it is percolated throughout the India. And it has been, farmers are finding that they have profitable business. Why that BT is not a nuisance for them, for BT once the BT brinjal
You
was
see,
there actually.
this physiological effect is observable only after 10 or 15 years.
No, but we are using all these transgenic canola oil and everything for that maize you are using, that the sweet corn. These are all
Yes.
transgenic. These are, and we are eating happily. And what is the effect? I think the more bad thing is that the climate actually, that pollution is the major killer rather than all this transgenic other stuff.
Okay. Professor Jha,
Yes, am I audible?
Yes, yes.
Yes. Please
The
go
basic
ahead.
issue that I want to raise in this, so that the pollution management technology, whatever be there, whatever technology that are being developed, the issue that had been raised in the forum is not being accepted by the farmers. So even if when any technology is being developed and not carried to farmers or not accepted by farmers, also is a point of issue that need to be seriously discussed, because uh, uh, actually a gamut of technologies have been developed and many of them have been rejected by the farmers. Why they are rejecting? And some incentives need to be in place so that any of the technology, when the cost is becomes important, whatever be the cost, because that is the basic issue now is within the agriculture system in India, where the price or the cost of production and the price of the harvest, that has become a challenge. So there, whenever the
Absolutely.
pollution issue comes, there need be some incentive in place. So those are the issues. I know the ICR technologies and that is available right now, but farmers are not accepting monitoring and incentive. Both need to be in place so that this be adapted. That's all.
Okay, I think we have to stop here because we still have one more talk. Thank you very much, Professor Manoj
Yeah,
Prasad.
thank you, sir.
It
Thank
was
you,
it was
everybody. Thank you.
excellent talk. It was excellent talk. It is
Thank you.
being appreciated by many of the
Thank
Thank you,
audience.
Professor Prasad. Thank you for
Thank
your
you. Thank
joining
you.
with us.
Thank you. Thank you. Thank you.
Thank you very much. Okay, so let us move to the next talk to be delivered by Professor Shantanu Jha. First, let us invite him as a speaker of this session, and he is going to be the last speaker. Professor Shantanu Jha is a professor of agricultural entomology and is in charge of Plant Protection Unit, Biran Chandra Krishi Vishwavidyalaya, State Aided Agricultural University of West Bengal. At the same time, he is honorary director of FPI and Horticulture Corporation and West Bengal Phytochemical and Pharmaceutical Development Corporation, Government of West Bengal. He is a member of West Bengal Pollution Control Board and so on and so forth. He is a member of many advisory committees, etc. Uh, to say about his contributions, he has diverse areas where he has made his contributions. One is intellectual property rights related activities, like he took leadership role in formulating and implementing People's Biodiversity Register, involving all stakeholders in conserving their own resources at Kalyani region. And for the sake of shortage of time, let me just summarize his thing. He has already guided 7 PhD students and 13 MSc students in projects. He has already 56 articles and 3 books or monograph or book chapter, and some other things are also there. But for the sake of time, I would like to stop here and I would invite Professor Shantanu Jha to deliver his valuable talk. Professor Jha, the floor is yours now.
Uh, yes.
Can you please share your
Yes. So now this is visible, no?
not yet?
Oh, is it? Mhm.
Professor Jha already shared his slides to me.
Yeah, you can also share from
If
your
you
side.
have any problem, then I may also share from my
Yeah,
side.
yeah. You better share it.
Okay, then just advise him when to go to the next one.
Yeah, yeah.
Chitto,
Okay,
please.
okay, wait. Is it visible?
Yes, this is visible to me.
Yeah, it's visible.
Okay.
Chito, please make it a full screen.
full
It
screen.
is now full.
No, it's not full
No,
screen.
it's not full.
Huh?
It's not full screen.
That is the problem. If I make it
Ah,
full, then it
okay.
cannot be operated.
No, it
Oh.
should be.
No, it won't be a problem. Okay.
So sometimes
Make,
this problem arises.
make it
Okay.
full, no problem.
Is
Make
it
it
okay?
Not really.
Across the yellow color, sir. Where written learn more and left side cross sign.
Is it okay? Is it moving?
No, no, no,
No.
no.
Oh.
Yeah,
স্যার
now,
ওই উপরে একটা
now you
এডিট
are in
মোড
the
আছে দেখুন,
second
উপরে
one.
এডিট মোডটা বন্ধ করতে হবে, ইয়েলো যে বারটা
Huh?
উপরে একটা ইয়েলো বার এসছে দেখুন, স্লাইডিং করে আছে।
দিলে হবে।
নাও ইউ ক্যান।
Where is that yellow bar? This one?
না না হয়ে গেছে, বললে হয়ে গেছিল,
Oh.
হয়ে গেছে। স্যার সব উড়ে চলে গেল তো, বন্ধ করে নতুন করে খুলুন।
Huh.
Professor Jha, this I call Jontrer Jontrona in Bengali, of course.
Okay. Wait.
We are waiting on demand.
Yes.
Yes. Now it's calm.
Is it
Now it's
okay?
perfect, sir.
Okay.
Yes, sir.
Yeah.
Okay, let's move.
It is okay.
Welcome you all in this discussion. And my topic of discussion is agriculture and food security in independent India, a journey with Dr. M.S. Swaminathan. As you understand and you already know that Professor Swaminathan has just passed away, and we are referring him in many aspects of agriculture, especially when you are talking about agriculture productivity increase and food security issue. Definitely in independent India, wherever it has been taken up for discussion, Professor Swaminathan was there with us, is there with us. So the issue that had been chosen here for discussion is a very important issue and need to be discussed very seriously. Next. Next, sir.
Next, already I.
No, it is not there.
Sir, you need to click on the
Yeah.
left. Yes.
Okay. So, if I talk of food insecurity, India was experiencing food production deficit even in 1930s. I want to request you to recall that when Burma got separated from British India in 1937, and during independence, western part of Punjab, eastern part of Bengal became part of Pakistan. So a real challenge in food deficit came in. Burma had a large share in pulse production. East Bengal was rice bowl. Western part of Punjab was important producer of wheat because it was in the irrigation network that time. And at that stage, food production fell to 62 million tons in 1957 to 58. So it was a journey which we were experiencing in food production deficit, and it took a very serious step. It reached a serious step in independent India, reaching the level of 62 million tons of food production. In 1943, Bengal famine took place, and you all know that different aspects of causes and these expressions of Bengal famine has been taken up for our research work also. Next. Yeah. And at that stage, India had to opt for Public Law 480, PL 480 agreement to get food aid with US in 1954. But at that time, food quality and other aspects also were related, and especially our policy issues had been influenced relating PL 480. So it was facing severe criticism in the parliament, in the political arena, and everywhere. There prevailed a concept that importing food grains become cheaper than the incentivization of a domestic agriculture production. That was the concept, especially the bureaucracy of India. They were of the opinion, what's the use of investing so much of money when we are to do many things in industrial sector and elsewhere for development of agriculture. Rather, straight away we can import food and meet the challenge of food deficit. During 61 to 65, food grain production growth halved from 3%, that is 3%, that is 1.5% growth. And then government of India understood the challenge. And Mr. C. Subramaniam, he was then industries minister. He had been given the charge of food and agriculture ministers. And you know that that time Mr. Lal Bahadur Shastri was our prime minister, and he was very serious about this. And Mr. Subramaniam uh, took up 2-point formula. One is provide price incentives to farmers so that they can take up production of food, and also emphasis had been given on science and technology application. Food grain purchases uh, still increased up to 1967. Next. Next, sir. Uh, at that stage, Ralph Cummings of Rockefeller Foundation advised government of India to use high-yielding wheat seeds, bringing it from Summit, Mexico. And such wheat seeds were imported and tested at IRI. Same thing happened in rice, and those had been found to be more productive. To be self-sufficient in food, government of India decided to adapt green revolution technology in agriculture. Actually, when we are talking about Dr. Swaminathan, Dr. M.S. Swaminathan at that stage started working in close collaboration with Dr. Norman Borlaug since the very first day of working with these dwarf HYVs in India, and continued to work in different capacities till his death. That's why whenever we are talking about agriculture food productivity and food security, always we are moving with Dr. M.S. Swaminathan throughout our independent India till his death. In 1968, in Rabi harvest, we got the result, and 30% more production took place using green revolution technology package. In 2 years, wheat production also doubled. Next. Next, sir. Now, what was the precondition of using these HYV technologies in agriculture? Use of chemical fertilizers luxuriously, use of synthetic pesticides, and use of irrigation water and farm mechanization. So you are to do this, and that is capital intensive. But at the core of the green revolution technology was genetically modified HYV developed through selective breeding, and that was a big jump that boosted big jump in productivity. Before that, whenever any problem to be dealt with in agriculture, production deficit, anything else, so dealing with the problems and managing the problem was our work. But only with this policy change, actually using this green revolution technology, a big jump in productivity had been emphasized and had been done also successfully at that stage. But dependence on limited genes like DG Wogan invited many problems later on, because a selective gene causing semi-dwarfing, and dependence on that also naturally make it vulnerable to many biotic challenges. Bacterial blight infection and tumorovirus disease in IR8, BPH infestation and Grassistan virus infection in IR20, and alike came up, and series of threat in Indian agriculture we are facing with. Dr. M.S. Swaminathan had worked in an Indian policy, agriculture policy level in different capacities. He was in IRI, was in CRRI. He had been given the charge of IRI. Then at one stage, he became a member of parliament. He was even deputy chairman, planning commission in India. In 1982, Dr. M.S. Swaminathan had been appointed as DG IRRI, IRI, with the target to combat the aforesaid challenges. What challenges? That is, poor genetic base in the use of this dwarfing gene, and the problems that Indian agriculture was encountering with. So, how to combat this challenge became a very important issue. It has been complained by the ecologists that at this juncture, with the help of Dr. M. Swaminathan, multinational companies producing high-yielding variety seeds paved their way to access this rice germplasm resources of India, especially collected at CRRI and elsewhere. Be this true or not, no one can ignore that Dr. M.S. Swaminathan's pivotal role in reconstructing the agriculture production system in independent India and facing the challenge at different periods. So that's why we'll be talking very seriously about Dr. M.S. Swaminathan's perception about green revolution technology, its fallout, what has happened even after 60 years, and be it ecological, economic, and alike. His prescriptions, his opinion became very important. Next. Yeah. Now I'll be discussing on this, the greatest challenge in Indian agriculture 60 years back and now, and how Dr. M.S. Swaminathan perceived it. I have already mentioned here, two major challenges have been found. One is ecological, another is economic. So far as ecological challenges are concerned, before that I want to say that when Dr. Swaminathan was subjected to criticism, he was talking about this ecological, because the basic challenge was it started from ecological point of view. Constraints of basic agricultural assets, that is there, land, water, biodiversity. There is major challenge because huge population is there in our country. Support from water resources, biodiversity resources, forest resources, so it has degraded like anything. Increasing productivity in perpetuity without ecological harm. That is the need of the area. We have experienced in states or provinces like Punjab, a green revolution state we can call it. Water table is going down, salinity increased. During green revolution, we need to understand that our population was 400 to 500 million. Now we are having 1.425 billion people. During 2030, we will be having 1.5 billion people. So to feed them, a perpetuation in food productivity increase is always a challenge. Now, when so far as the ecological point of view, Dr. M.S. Swaminathan was of the opinion that we need to look at the negative impacts of green revolution technology, but this must be accepted that this green revolution technology has released land for us for production or other purposes increasing the productivity of a crop. And second is, this technology is also forest saving. That is, forest land can well be available to increase its area so that the productivity per unit of land area be increasing. But so far as this sustainability uh, uh, or brings an impact in soil and our total biotic system, use of DDT, we are faced the challenge of 3 R's: resistance, resurgence, replacement. So it gradually become a very serious threat of our climate, of our environment. So this need to be accepted, and Dr. Swaminathan was conscious about it. Next, so far as economics of farming is concerned, uh, basically agriculture need to be profitable. And now, when this economics comes into core of our agenda, we must be calling it as because sustainability in agriculture production also becomes in core of our discussion. Sustainability and food security is continually being discussed in an agriculture scenario. Uh, Two agriculture scientists or the farmers also lowering cost of production and reducing the risk of agriculture pests and pathogens took a center stage. And today, return in agriculture, we need to understand is adverse to farmers. And that is the issue that has taken a serious, especially when we took leadership role in Farmers Commission that has exhaustively analyzed our problems in agriculture in our country. Addressing the economic challenge that requires more public policy intervention was the call of Professor M.S. Swaminathan. He has raised the issue or the committee that exhaustively analyzed the problems related with Indian agriculture, crisis in Indian agriculture. So the issue of MSP, especially C2 plus 50, that is 50% more than the weighted average cost of production, uh, became the one of the very important agenda. Agenda of doubling the farmers' income by 2022 could not be achieved. It had been actually it was a call by government of India that we are to double our productivity, but that could not be achieved. Swaminathan's report, that is Farmers Commission's report, was not implemented. Farmers' movement even marks the dissatisfaction of them on the modified farm laws during COVID-19. So far as economics are concerned, another very important agenda is with farm loan waiver. Bigger burden our in our country's exchequer is through higher pay of farm produce. Government is not prepared to spend 20,000 crore for higher MSP. In 2009 only, 72,000 crore conversely had been spent for farm loan waiver. So that was very important economic issue that had been raised by Professor Swaminathan so far as economic issues related with Indian agriculture is concerned. For improving income, he emphasized on MSP and MSP, the C2 and plus 50 is the formula that he presented before us. And second is increase in the marketable surplus to be enhanced. And third is value addition to biomass. That was the issue that was being interacted or discussed in the last presentation, at the fag end of the last presentation. That is rice straw burning or wheat straw burning. So that need to be reused. I was drawing the attention of the August Assembly about acceptance or non-acceptance of a technology that is being developed. A theory is there, rejection theory. Why the farmers to reject a technology is very important. Some incentive need to be there. And here, Professor Swaminathan also emphasized on this, that rice straw can well be used for cultivation of edible mushroom and all those as the best material. So those are to be emphasized for improving the income of the farmers. Next. Next, sir. Now, so far as the meeting the challenge of inability to pay off the debts, reduction of the cost of farm production, minimization of the risk, maximization of the return, not paying the compensation enough is another very issue. And presently, all policies he drew our attention towards this and commented even at the fag end of his life is related to corporates. So that is the basic challenge our agriculture in India is facing with. Next. Next slide. Now, if we look at the Green Revolution 67 to 68, whatever this concept has been brought in. Now, he at the fag end of his life actually opted for evergreen revolution concept. And here, a few of the issues become very important. One is increase in farm productivity without ecological harm. With the experience of using DDT in agriculture fields, we have learned a lot from that. And switching over from that technology, chemical technology, to judicious use of technologies in the form of integrated pest management, integrated nutrient supply management, scientific water management, upon which he emphasized on. Mandatory rainwater harvesting, introduction of fodder and legume as rotation crops with wheat, sustainability in farming. Yeah, I want to focus on this. The sustainability becomes very important at this stage. Sustainability becomes, as it were, a matrix, an amniotic cocoon within which he developed his later concepts. A work against once said that sustainability, like the nation state, is a refuge of the scoundrels and dissenting self-reflective. Sustainability and food security are the two concepts seem to compete in his scheme. If the earlier Green Revolution talked of security, productivity, and national security that I referred in the early part of my discussion, Dr. Swaminathan felt that from security of our nation to food security, that needs to be a very important journey. This needs to be treated in that way. Security is a network of concept. Food security, security of to security of livelihood, to ecological security. So if all these three factors put together, then only that will be a sustainable security system. And when we are talking about food security, not just availability of food, this needs economic access to it is also equally important. Otherwise, we cannot face the challenge of malnourishment, that is denial of access to food. And this is more focused on women, children, and the marginals. And the poor, why a person is a poor? Because 30 crore of people is below the poverty line, especially the farming people, they are mostly poor. Now these poor people, they don't have much of asset. That's why they are poor. So in that condition, because Professor Swaminathan developed his view at the fag end of the Green Revolution technology he has made use of, he was much concerned about the experience of the farmers of the Punjab, and later on whole of later part of 2-3 crops. So that can be treated as fertile zone, then to special agriculture zone, and where some specific support, unique facilities to be extended to the farmers. If we talk of our state, say Gangetic alluvium, when we are talking about the productivity is much higher, whatever the new technologies that are being adapted in through green revolution technology and evergreen technology to biotechnology, whatever the agriculture be there. So in this region, that can be adapted very fast. But so far as special agriculture zone is concerned, think about the red lateritic zone, think about the saline zone, think about the hilly terrain. So you need to extend specific, unique facilities to the farmer so that in those areas also agriculture can go ahead with those supports. Appointment of soil health manager. I was talking about the saline tract. So if very closely the soil in those areas be not ameliorated, monitored, so gradually those will be degraded. Rectifying defects like salinity, alkalinity, waterlogging. So special focus need to be given on those. Next. Now, so far as now issues related with claimed benefits of genetic modification technique, because that is another issue. Now, even at this period, it is being debated in our country. Now, genetically modified crops, they have both advantage and before reaching a conclusion using GM technology. MS Swaminathan Research Foundation, they use GM technology with mangrove to create soil tolerant variety of rice that had been developed there. And his prescription was that you choose a problem and then you find out the way, and there where the GM will be used be decided in that way. GM in most cases, in his view, was not necessary. He was of the view or trusting more on Mendelian breeding system. Maybe I don't think that through age or the elderly, he was of older technology. He was of the opinion of adapting older technology. He was always in an open mind to accept newer ones, but he always was of the opinion or in favor of more of Mendelian breeding system. Next. Uh, while he was talking about the organic farming, which is being now treated as panacea in facing the equal challenge and also economic challenge in agriculture, he was of the opinion that three conditions are required for adoption of such organic farming technology. One, the farmers must possess animals for organic manure. Two, the farmers must have capacity to control pests and diseases. Three, the farmers need to adapt agronomic methods like crop rotation, genetic resistance to pests and diseases. These help organic farmers. Please. Uh, Next line. Yeah, and is always needed. So far as organic farming is concerned, that is the need. Now is the issue which we cannot avoid whenever we talk about agriculture is climate change, and how to address the climate change for our sustainability in agriculture. That was always in our Swaminathan also was thinking about it. He did a lot in this area, and he also was of the view that India is more vulnerable to climate change due to huge population dependent on agriculture and excessive pressure on natural resources. I've already told in my earlier part of my discussion that the degradation of natural resources gradually taking a very serious step, and poor coping mechanisms also are there. The warming trend in India over past 100 years indicates increase of 0.60 degrees centigrade. The projected temperature high impact naturally would bring in impact, and the projected impact is likely to further aggravate field fluctuation of many crop impacting food security. Next slide, please. So far as agriculture is concerned, it makes up roughly 15% of India's GDP. 4.5 to 9% negative impact on production implies cost of climate change to be roughly at 1.5% of GDP per year. Huge. Enhancing agriculture productivity is critical for ensuring food and nutritional security, particularly the resource poor farmers would be affected most. I have already told that while food security is who I was talking about. Climate change might result in price hike of agriculture commodities, feed supplies, and consequently livestock products like meat, milk, and others. Next slide. Yeah. And in the absence of planned adaptation, because this is now almost accepted that the climate is changing, and projection of change I have already told, and how to adapt with this change. The consequence of long-term climate change could be severe on the livelihood security of the poor, especially. So that is very important issue, and we need to develop a coping mechanism at policy level too. Next. Now, a significant decline in production is also perceived due to climate change. How? By shortening of growing period, and also will have negative impact on reproduction and grain filling, particularly due to terminal heat stress and decreased water availability. And already at different years, we are facing this even in our state. So far as biodiversity is concerned, it would also be adversely affected. Will affect agriculture production also in that way. One point I want to mention here, that poor people, they are more dependent on genetic diversity. So they will be affected more in climate change. Next. So let's pull down. Climate resilient agriculture encompasses adaptation and mitigation strategies and the effective use of biodiversity at all levels, be it at the level of genes, at the level of species, at the level of ecosystem itself, and is thus an essential prerequisite for sustainable development in the face of changing climate. Next. Next slide. The Indian agriculture production system is to fit. In earlier slides, in earlier presentation also, it had been taken up for discussion. 17.5% of the global population with only 2.4% of land and 4% of the water resource at its disposal. So what big challenge we have to face with, we can easily understand. With continuously degradation of natural resources base, we have to feed our people. Increased frequency and intensity of extreme weather events also impacting our agriculture very severely. Next slide, please. Yeah, the challenge is formidable because more has to be produced with reduced carbon footprint and carbon and water footprint. And that is here also the ecological point of view is very important. Climate change impacts agriculture both directly and indirectly. The key influences are change in productivity with reference to quantity and quality of crops, change in agriculture practices like water use and application of fertilizers, insecticides, herbicides, when it is to be applied and when not, what is to be avoided and what is to be adapted. That becomes actually a changing steps are to be taken. Environmental influences, particularly in relation to the frequency and intensity of soil drainage, which may lead to loss of nitrogen through leaching, soil erosion, and reduction of crop diversity, becomes very important influence in agriculture in our country. Next. Next slide. We are talking about global hunger index. We are in a very, very poor condition. India done well. It was Professor Swaminathan's last view he expressed. India has done well in production, but not in consumption. Grain mountains on one side, but hungry millions on the other. Food Security Act needs to be implemented, he was of the opinion. Nutri-millets have been talked a lot about it. This I am not enlarging. Enlarge the food basket to Nutri-millet. Next. So a series of recommendations Professor Swaminathan has made. But before going into that, I want to draw attention towards the policy challenges faced by Indian agriculture very precisely. One, globalization challenge, volatility in prices. Second is dry land farming and their challenges. Third is environmental stresses that I have discussed a lot here. Now, what are the deficits in Indian agriculture? One, investment, credit, and infrastructure deficit. Two, research and extension of technology deficit. Yeah, I'll be talking about. You need not move this slide. Research and extension of technology deficit. Market deficit. Access to market is always very important. Whatever the good crop is being harvested, farmers are not achieving out of that, and that's due to market deficit. Fourth is diversification deficit. Fifth is institutional deficit. Sixth is education and skill deficits. So these are the 6 deficits that have been identified, and small farmers can respond positively only in the presence of adequate infrastructure, without which the Indian agriculture with poor farmers cannot go ahead with. One very important issue is 4% growth in agriculture need to be met with. Equity in terms of higher growth in lagging region. Say, if Gangetic alluvium, the soil of Gangetic alluvium is being used for commercial crops, so where from we'll be getting our food? That is basic challenge. So these lagging regions need to be properly addressed. Professor Swaminathan has also mentioned about this. Small and marginal farmers and women also need to be addressed in equity terms. And third is sustainability. I have discussed a lot about that. And yeah, the provisions in the food security bill, about which Professor Swaminathan mentioned in the last point I was discussing about, every person belonging to priority households identified under subsection 1 of section 15 shall be entitled to receive 5 kg of food grain per person per month, as at subsidized price specified in Schedule 1 from the state government under TDP. So in Antodaya Yojana. So these are the steps that had been suggested in food security bill, which has not been properly implemented. Not to talk of the situation that we are finding in our state, even in COVID-19 situation, when food is to be access to food need to be facilitated by government through public distribution system. How that had been looted, that is coming before us. Now, very precisely, 10-point program had been floated by Professor Swaminathan. One is building resilience in soil. 2, adapted cultivars and cropping system. 3, rainwater harvesting and recycling. 4, water saving technologies to be adapted. 5th, farm machinery, that is custom hiring system centers need to be developed. Crop contingency plans have to be developed to face the challenge of climate change, especially. Livestock and fishery interventions are more important, that need to be focused with. Weather-based agro advisory services need to be extended. Institutional interventions, about which I drew the attention in my point just a few minutes back, he also emphasized on that. And last one, Village Climate Risk Management Committee, he proposed, and Indian Council of Agriculture Research is working with this, but not up to the level, the need that we are facing or feeling in our country. Next. So very precisely, these were the points that had been brought. I very precisely started the journey of the discussion with the food deficit in pre-independence era, with the experience of Bengal famine, policy level interventions also there, because we still recall that that food which was in our reserve in eastern part of India had been sent to war fronts, and we encountered with Bengal famine. And then green revolution technology, how it had been adapted, food production security, we to some extent we achieved, but from food production technology to food security issue that had been narrated and had been discussed, critically discussed by Professor Swaminathan. Whatever the criticism about green revolution technology that is there, and Dr. Swaminathan had been criticized about that, but we can't ignore Professor Swaminathan's role in whole of Indian agriculture throughout independent area till his death. So with this, I express my gratitude to the organizers for inviting me to talk on this, and also mm, I, as an agriculture scientist, express my pranam, give my pranam to Professor Swaminathan in memory of him. Such discussion should be taken up. Thank you, sir. Thank you for conducting such lecture.
Thank you very much, Professor Jha. It was a fantastic talk, describing clearly the vision and actions of late Professor Swaminathan, very lucidly and also very critically. So we may entertain one or two questions if they are there. So it is now open for questioning and interactions.
So, hello, Professor Jha.
Yes, I'm here.
Thank you for your elaborate discussion
Yeah.
on the problems and prospect of the Swaminathan's recommendation. And in fact, the Indian economy is dependent on this agriculture majorly,
Absolutely.
and this agriculture is creating the problem today. The farmers, say rich farmers or poor farmers, who are happy in my country. In the last agitation of the farmers in Punjab side, that had proven it. Neither the bigger or the poor, they are happy with the laws and the management of the government of India. That is one part. Regarding the environmental issue, you have mentioned about the salinity of soil. Soil salinity is increasing, even considering all sorts of problems. That means the right implementation of the Swaminathan's proposal, or the what our president told that lab to land, laboratory from researcher to the farmers, that there is a gap. And how it is possible to manage so that the restoration of the farming side of the country. Since today, even in Bengal, the farmers are not happy to cultivate. Since what they are purchasing for their cultivation, see either water, electricity, or the pesticides, fertilizers, everything, they are very costly. While when they are selling their product,
205,
they
sir.
are not getting the equal value. How can you manage it?
Would I respond to?
Yes, sir. Yes, sir. Yes, sir.
Yeah. While I was making my presentation, I drew your attention towards 6 deficits in agriculture. One is investment, credit, and infrastructure deficit. Second is research and extension extension of technologies and the deficit there be. Third is market deficit. Fourth is diversification deficit. Fifth is institutional deficit. Sixth is educational and skill deficit. Now, so far as farmers are concerned, I will be putting the issues in three issues. One is because basically Indian farmers are poor farmers. Basically, a few rich, so far as this northern part of India is concerned, where green revolution technology had been adapted, you'll be getting rich farmers. So that is very interesting. That farmers' movement at the core of the issues was the recommendation of Professor M.S. Swaminathan, the Farmers Commission's report about the ensuring the minimum support price. So that was the issue that had not been addressed by the government, and this need to be done because there is no other option. The food, there is no alternative. Even today, if someone thinks that food import is had the experience, so that experience need to be taken into consideration. Second issue is, so far as pricing is concerned, that is supporting farmers with price incentives. One is subsidization of the inputs which are totally under control of corporates, the seed, the fertilizer, the pesticides, whatever be there in use. And secondly, at least a minimum support price to be extended. This is one jugglery in the market, where market system is not always logical. You cannot explain logically why the market price in certain periods is growing up and why in certain situation it is going down. No market logic will be available. That is a totally artificially created market situation where the poor farmers cannot influence the policy at that level. So that is very important where the steps to be taken. The farmers movement, we should remember a policy change in farm laws. Actually, that was opposed by the farmers, and that was something a battle between the industrial corporate houses and rich farmers. That was the battle. So in that case, the naturally whatever the experience that you have seen and we have gone through that. So so far as farmers' dissatisfaction is concerned, that is very simply one is that the cost of inputs are growing very rapidly, and the value of the produce they are not getting. So access to market. So three accesses are very important. One is access to credit. Towards that, the Farmers Commission report drew our attention, and institutional credit need to be extended in proper time to the farmers. Second is access to skill that I have already told, that need to be developed gradually and always, facing whatever the challenges that you are facing. So far as ecological challenge, that is very important. And third is access to market. What we do find in our state? Have you ever seen the Kisan mandis throughout our state? The agriculture farms from the state government farm, agriculture Kisan mandis have been developed, established, and 90% of the Kisan mandis are not in use. So that is not well planned. So helping farmers accessing the market in the form of cooperatives and others need to be boosted. Otherwise, they cannot bargain with their produce with the bigger markets. So that is very important issue that need to be taken into consideration if you are to bring in satisfaction to of the farmer. Yes, there another question is there.
Yeah, Professor Jha, as I see, there is another problem which is not really addressed very much by nobody. Even the governments are not addressing to it. For some reason or other, a section of so-called farmers, they are getting much of money and they are purchasing land. So basically, they are now playing the role of corporates, and the other poor farmers, they are just working just like workers. So basically, this farmer category is going to be destroyed in the coming years. So there will be again laborers and corporates. What is your comment on this? This is
Yeah.
an obvious thing, no?
Yeah, that was a very fantastic comment. Green revolution became red was a comment after the economic fallout of green revolution technology while adapted in India, and we do find it that smallholders they go out of the agriculture arena, become agricultural laborers, and
Yes, sir.
huge data are available. So that is happening in a more aggressive manner when we are in this neoliberal economic policy and the system that is globalization that I was talking about. Because so far as policy challenges, I enlisted in my talk. One is globalization challenge, volatility in prices challenge. So that is very important. And so far as this small and marginal farmers are concerned, I would draw your attention towards this, that initially, when patta had been given, or the land reform that took place in Bengal, the patta had been given, and some small pieces of lands had been given to farmers. They initially made use of those lands gainfully. But later on, after in the neoliberal economic policies, now simply the value of that land is some 500 rupees per vigha per month. That is the rent value, not more than that. That is in a year, 6,000, 8,000, 10,000 maximum a year they can get as a rent of that land. And those lands are now being accumulated by others, rich farmers. Even gradually, it will go out of their hand and will
Right.
be in the hands of the corporates. Straightway, they won't be purchasing, but they will be accumulating those land, and that will bring impact in food security in more serious manner, possibly in coming days. That we perceive. That is a very big challenge now we are facing with.
Okay, maybe we entertain the last question from Professor Bera. Professor Bera, please.
Professor Jha, I have impression that Dr. Swaminathan does not like the genetically improved food. Is it true?
Yeah, he didn't like. He was almost. I at the back end of my presentation, I mentioned that Professor Swaminathan was critical about GM crops. He didn't
Yes.
support, and uselessly we are running after this, and also biotechnological technology. Also, he was not in support. Very selectively, genetic modification can well be used. And one example I gave that had been adapted in Professor Swaminathan Foundation's Institute, where they made use of this some of the plants of saline tract that they use for salinity tolerance development in rice. In that way, in certain challenging points only, these technologies need to be used, otherwise not. He was very critical of GM crop.
Is it not against scientific view?
I'll be telling two issues. Straightway, the science has no problem with this. But the problem is that the economic policy behind it. He was also of that view. Because gradually the seed becomes seed of dependence. We have learned a lot before our independence to present day agriculture in our country, that seed of dependence is always a threat for economic security, even national security. That's why PL variety had been combated. Now, when the reforms had been brought in before globalization, change in seed policy, change in patent policy, because technology is being developed, but technology is being controlled through these laws and patent laws and others. Through that, control over the total production system is being taken up, and that is policy influencing method. So far as GM technology is concerned, that is more important in that way, because that is seed of dependence. One seed cannot be reused. So every year you will have to make use of the seed, you will have to purchase it, and it's very costly. When the cost of production getting were jumping higher and higher, and the production and the whatever the produce we are getting, their prices the farmers are not getting. So when the problem or challenges be there, then using technology also will have to be selective. That was his view, and that's why he was a bit critical about GM technology, not for scientific view, but so far as social and economic context is concerned in countries like ours.
Thank you very much. So we have to stop here. I would like to thank all the three eminent speakers for their brilliant presentations. Professor Shantanu Jha going in the opposite way, Professor Shantanu Jha, then Dr. Manoj Prasad, and our Professor Chittaranjan Sinha. So thank you very much. Now I hand over the mic to Gauri. Gauri,
Yes,
are you
sir.
there?
Yes, sir. Yes, sir. Am I audible?
Yes, you are audible.
So thank you
Now
very
the
much.
floor is yours to
So
continue.
thank you very much. I will thank all the participants for joining this session within a very short call. First, I would like to thank our President, Professor Nitin Chakrabarty, and our Secretary, Professor Chittaranjan Sinha, that they have took a nice decision to arrange these types of session where we can pay our tribute to a great scientist of our country, as well as we can discuss our real problem. That is the sir has told, that is laboratory to land. We are facing a problem on that. So I think there are some young scientists of future. They are participated today, so they will think on it. I will
Please,
also like.
I would request you to kindly invite all the audience to join in our KIIT program.
Yes, sir. I will invite it.
Yes.
So I will also like to thank our chairman, sir, Dr. Lakhan Chandra Seth, who has established so many educational institutes in Eastern India, where almost every subject is nowadays is taught, and he is an inspiration to all of us. In his 75 years of age, he has completed his PhD and D.Litt also. So this is also a new inspiration to our students who have joined today. I will also thank to uh, our principal, sir, Professor Subrata Mondal, our registrar, Dr. Anjan Mishra, our dean, Professor Asit Baron Maiti, who has given us the permission to organize this seminar within a very short call. I will also like to thank our Dean of Student Welfare, Rajiv Kumar Dubey, who have helped a lot to organize different perspectives. And I will also thank our HOD, Professor Deepak Kumar Janna, who is not today within this meeting. He is in abroad in a Korea in an academic program. But from outside also, he has guided us in several ways. And in his absence, our HOD in charge, Dr. Anupam De, who has helped a lot in last 2 days to organize this seminar. I think it is successful due to his wholehearted support. I will also thank all the faculty members of our chemistry department, physics department, mathematics department, English department, and also we have invited some other departmental students and their faculties to join in the program in the YouTube streaming, because in the Google Meet we can accumulate only 100 participants. So I think nearly more than 200 or 300 participants are joining in the YouTube streaming. I am also thankful to them that they have joined in this program and make this they make this program a successful one. And we are paying a tribute to our father of green revolution, Professor Swaminathan, in a honest manner. We will also thankful to our office staff, Mosarab Babu, who has helped us a lot. And at the end, I will thank to all participants. And now, last but not the least, our three speakers, without whom this program was not possible, like Professor Manoj Babu and Professor Jha, and obviously our own secretary, Professor Chittaranjan Sinha, who had given us a lot of information, starting from this GM technology, biotechnology, the food security of India, especially Professor Jha has told, before independence, after independence, and when the country was divided, our big country was divided, how the problem created from the East Pakistan, West Pakistan, Burma. That is a probably a new type of information to a new generation, because nowadays the students do not learn history properly, history of science properly. So that is a very valuable information to all of us. So at the outset, I will thank to everyone to make this program successful. Thank you. And a very another invitation from the Indian Photobiology Society, that in 18, 19, and 20th November, we are organizing our annual convention, where so many eminent speakers inside the country and outside the country, they will join with us. So I will invite all the audience today to join in our program there. And it will be organized in Kalinga Institute of Technology, popularly known as KIT, Bhubaneswar. They have a beautiful campus. So, and in Bhubaneswar, there is the Lingaraj Mandir is there, and very near to Puri. So you can join the program, as well as you can also have some holiday program within the Odisha. So I will invite all of you to join there. And with these words, I again thank to all the participants today joined. Thank you.
Thank you very much. Thank you very much.
Before closing, let me to inform you that one of the senior most scientists of the country, who is running 85, he joined in this program. He was Durairajan Balasubramanian, Padma
Yes,
Shri.
yes,
His full program, he was with us. Just
yes.
few minutes ahead, he left.
I saw him. I saw him
Huh.
there.
So I think we may invite him. He was in the director of L.V. Prasad Eye Foundation, as well as he was the chairman of Indian Academy of Sciences.
Right.
So it is, in fact, a good fortune for the Indian Photobiology Society also.
That's true.
So thank you, sir. Sir, just to close and to give your thanks.
So we are closing this session for this time, and please keep contact with us and get information for our next monthly science talk, which will take place on the last Saturday evening 7. Okay. Thank you very much. Bye. Good night.
Thanks to the chair.
Thank you, sir. Thank you, sir. Professor Bera, sir.
Thank
Shubha
you.
Vijaya, sir. Shubha Vijaya. Pranam neven, sir.
শুভ বিজয়, ভালো থেকো।
ভালো থাকবেন স্যার। হ্যাঁ, সবাইকে শুভ বিজয় যারা এখানে আছেন। বাহ, খুব ভালো হলো আজকে।